So last time we finished task 2 completely, but we didn't get time to start the drawing for task 1. So we're going to do the drawing for task 1 first. So I go to the open part here. Make sure that you're in the correct project. I might just do that first, just to show you. So I've got my black check mark on the practice task 1 project. But if you're now sitting at another computer than what you're usually sitting at, then you probably won't see your previous projects in the list there. So the way to figure out where they are then is to go down to the browse button down here. Then you go to my computer, to the H server. Again, to the H server, you find the folder where the project is. In this case, it's task 1 for the B group, in my case here. And there I have my project file. So then I can open this one and it's going to be activated. When I've done that, I go up to the open folder and then I open my part file because I want that one open in the background. There, I've got my plate open. I'm just going to double check that we've already set the material. We did that, so this one is ready to be made a drawing of. So then I go up to the new sheet up there, a blank sheet of paper. So I click on that one. I choose the metric folder. And I go down to the iso.idw file. That is, there are two different file types here. It's .dwg and there is .idw. And it's the IDW that we want. It's the one that is native to Inventor. The other one is a more generic type, which can sometimes cause a little bit of trouble when we're creating drawings, so we want to use the native one, which is purpose made for what we're going to do. So the iso.idw, click create. And since I have the part file open in a different tab down here now, once I want to click my base view up there, it's going to automatically select the plate for this task. So I want to make sure that I have this one marked, hidden lines removed, because I don't want any hidden lines being shown in my drawing. And I also want to tilt mine a little bit. I don't want to look at it from the side like this. I want to look at it from the top. So I tilt it around there. But then we can also see that it's fairly small compared to the size of my sheet, so I'm going to try to change the scale also. So I changed the scale to 1:1 instead of 1:2. That looks better. And before I press the OK button, I'm going to place a projected view on the side here. And then I click the OK button. So now I have the plate itself, and I have a projected view where I can see the thickness of the plate. And I'm going to just drag and drop the view a bit further up here just to get room to place all of my dimensions.
This file.
I'll start off by showing where the symmetry line is on the drawing here. So I switch toolbar from the Place Views toolbar to the Annotate one up top there. And in Inventor, we just use the center line function, even though it's a symmetry line we're going to show, because the lines themselves look the same. So I click the center line function, and in this case we have the center line going horizontally through the entire plate. So I click on this edge, and then I click on this one, and then you can see that after I placed the center line itself, it still follows my mouse pointer around, so it wants to place more center line as I go along here. But I don't want to place anything else right now, so I right click on my mouse and click Create, because then I get it set there. So now I can start off by giving the width of the plate here. I can give that across the entire width, because the symmetry line is going to show that it is symmetrical on each side. So I use the regular dimension function, general dimensions. I click the top line of the plate, and then I click the bottom line. And now I see already that I've forgotten something, because I haven't changed the format of the dimension. So I need to go up here to the Format section and choose method 1b, because then it's not showing all of the .00s there. So I place the dimension, and then I click OK. I need to give one more width dimension for this one, because I need to know the width across this tip here on the plate. So I need to give the dimension over that one also. So I continue placing dimensions from the top of the tip to the bottom of the tip. I place it there. And OK. And the nice part now is that I have 180 on this side, and I have 60 on this side. And since both of the dimensions are symmetrical across the symmetry line, this part here has to be 60, and the part up top also has to be 60. So I don't need to actually put dimensions on those. Now we can start putting dimensions on the length of the plate. I'm going to start at the back point here. I'm going to move forward to this point, so that I'm giving the horizontal length of this angled line. And then I place the dimension here. And then I'll continue from the same point, give the dimension from there and over to this edge. And what I want now is to have all of my dimension lines in line. So I want everything showing on one long line here. So what I do is I move my mouse pointer over to the previous dimension. Then you see it turns red, and I get this yellow dot following my mouse pointer around. So if I just pull it back over here, then the new dimension is locked into place right beside the previous one. So click OK. So that looks really nice when you're reading a drawing. It makes it a lot easier to read it. Then we need one last horizontal length. We need from this edge to the tip of the plate. And I do the same to get this dimension into line. Move the mouse pointer over until I get the yellow dot, and then I place it. Then I'll place the thickness of the plate in here. And then I try to position my mouse pointer so that I don't get any green dots there, that I'm just marking the line itself as red. So when I click the line, I get just the thickness of the line there. And again, I want it actually to be in line with these dimensions. So I do the same here. Even though I have free space between them here, I can still get it on the same line by holding my mouse pointer over here, getting the yellow dot, and then moving it carefully over here. And already at this point, I can place my dimension there. So I can click my mouse button, then it's set in place. And if you put a ruler on the sheet of paper once you've printed it, you'll see that this is one, everything here is on one line. Now we need to give dimensions to the rounded edges, the fillets that we made on this plate. So we have 4 of them that are the same radius, and then we have 2 that are a bit smaller. So we're going to give a dimension to one of the 4 large. We're going to put dimension on one of those, and we're going to add some text behind the dimension. We're going to write in tip for typical, just to show that the other fillets that looks to be the same size are actually the same size. So we're going to put this one in here. So I get R20 inside this one. I click my mouse button, but I don't click OK yet because I'm going to add my information into here. So I create a parenthesis and I write in tip. Tip is just a shortening of typical, so it's the one we use. Once that is done, I press OK. And now it says that I have R20 and it's typical. But if I leave the drawing like this, it is actually saying that all of these edges are going to be R20. But we know that these 2 in the front, they're actually half that. They're just R10. So we need to put dimensions on those 2. So I mark one, put the dimension in, press OK, and then I mark the other.
Move your mouse and zoom in. No. That's where you want to go. You zoom in. Press here. Not on the screen. Like this. Press it. And then change it up here. Right. This. Okay. Did you get that? Dimension. Press the circle when it's or the rounded edge, but not when it's green. What do you want to measure? Yeah, then press them. If that's what you want to measure, then not when it's green. Press dimension. So zoom in.
Oh,
where do you want to measure? Yeah, then zoom in there. Roll your mouse towards. So one more. One more. Yeah, okay. Now, press dimension. Press the rounded edge, but not when it's green. So go to the rounded edge where you want to measure. Not green. Perfect. Press. Then you change. By standard, you need to change it to 1B. Yeah. Yeah. Then hold up. Dimension. You always need to have 1B. This is not 1B, this is not 1B. needs to say 60, not 0.0.
Because even though they install about 17 inch computer, unless it's open, it's not going to automatically fire.
Press it. Just make sure that this is out, so press escape. So nothing is blue, okay? So then you press this.
This one?
No, it only says 60.
Yeah, now it's open. 17. So probably that computer hasn't been used before.
Everything should be one. Okay.
Yeah, you're getting that
double
green
click.
dot. Place it. So instead, use the green dot. Just see the green dot, and then you just move it.
One more, come on.
Green dot to
Oh, no.
this way. Yeah.
Yeah, perfect.
There.
And space.
No, now you got the green dot again. So try to avoid the line.
Oh.
So when you're in the middle there, you're getting the green dot. So right there, yeah. They have all this. Yeah, so that's when you get it.
Hold and shift. And press 8. Now we write TYP in big letters. TYP for typical.
Right, then we're at the point where we've gotten all of the dimensions onto a drawing. So now I'm going to place a parts list so that we will get to show what material the plate is made of. And in order to place the parts list, I go up there. It says part lists in large letters, so it should be easy to find. I click this one, and it tells me to select the view. Now normally, during this course, you will only have one view to basically select here. You have a projected view and everything, but everything is connected to the same part file. So it's never going to be a problem for you in here, but in a working situation where you might have showing more than one part in a drawing, you have to select the correct one in order to get the parts list. But here you can just select whatever view you want, because you're only going to get the same no matter what you choose. So there, okay. Now the parts list is following my mouse pointer around. So I just place it down in the corner here. And now I'm going to double click on my parts list so that I can start editing it. Then I get this window up. And if I go up to this button that says Table Layout, I get a chance to remove the parts list title from the table. So I go into the table layout, and you see that I have parts list written up top there, and it also says title with a checkbox beside it. So I'm just going to uncheck that box, because then I remove the entire title line from the table. So I go down and press OK. Nothing has been updated here yet. It takes a while before that happens. So before we get it updated, I'm going to go up to the column chooser button. So enter the column chooser. And now I want all of these columns away. So I have item, quantity, part number, and description. None of those tells me which material the plate is. So I don't want any of those. But I do want a column that says material. So I'm going to mark one of the selected properties up here. So I'll just start off with item up there. And then I click remove. I do the same for quantity, part number, and description. Then I go over to the other side where it says available properties. And I just scroll a bit down until I find one that says material. And then I click the add button. So now I have one selected property, which is material, which means that my table is basically just going to be one column, and it's just going to show the material. So I click OK. We even got it up here. It's been updated here, showing material aluminium. It's not updated out here yet, but we can click apply to get to see it if we want to. It will also be automatically applied if you just press the OK button directly. So now you can either choose to have it on a double line like this, or you can drag and expand the column a bit just to get everything on one line. That's also a possibility. It's not a problem having it shown on two lines at all. It's just whatever you... Yeah, 60-68. And here you actually see that this is it's an American company that's making this software, because they're saying aluminum, not aluminium. They're the only country in the world that says aluminum for some reason. Everyone else have agreed on saying aluminium instead of aluminum. But then again, they use inches, so there's no helping them. Yeah, I think it's the United States, and it's one or two other countries that use inches. Still, even Great Britain has changed over to the metric system. So. Now we're going to add a note section here, where we're giving the general tolerances of this one, because up until now we're only giving the precise dimensions of everything. But whoever is going to manufacture this wants to know how many micrometers is it allowed to deviate from this exact dimension. So then they need to have some information. So we go up to the text box up here. Click text. And for now I'm just going to place it randomly here somewhere, because I'm going to have to move it afterwards when I see exactly where my text is. So I click it up here. And then I'm going to write general tolerances and surface finish. So general tolerances and surface finish. And I'm going to start a new line. And on the new line I'm going to reference two ISO standards, and also the degree of tolerance that's going to be used. So I'm going to reference ISO 2768-1. That is the first one. And it gives the tolerances for linear dimensions and angular dimensions. And in this case, we want it to be medium. The next one we're going to reference is ISO 2768-2. So it's basically the same ISO, it's just part 1 and part 2 of the same ISO. And this one is going to be K, capital K. Because this one gives the general tolerances for more the geometrics of the part. So if it's how parallel lines are going to be, the straightness of it, and everything like that. Concentricity, if it's cylindrical. That's what the K does. And the K is equivalent to the M in this case, so it's a medium tolerance. Exactly why they couldn't use fine, medium, coarse, and very coarse on that one also, I don't quite know, but for some reason they've decided to keep them separate. The surface finish, we can't really put in here, we have to add it as a symbol afterwards. So once this has been added, we can click OK. And now we also see exactly where our text is. So now I can move it down to rest on top of the title box. So I right-click my mouse button and press OK, or use the escape button on the keyboard. I mark the text box so that it becomes red, and I can just drag it down here and place it right above the title box. Then we're going to add the surface finish information, and then we have to go up to this part up here, which is symbols. And we want the one that's aptly named surface. Once the surface symbol has been marked, I have this, almost looks like a check mark that is following my mouse pointer around. So I move this down to the top of the title box. It's not going to automatically snap to it until I actually place it. So you just move it as well as you can to the top of the title box. Then first you click your left mouse button, and then you click your right mouse button, because then you can click continue, and then you place it. The reason for this, which I'm just going to show now, is that if you just click your left mouse button and you then move your mouse pointer, you can place the symbol itself far away and have a line with an arrow pointing to the surface that's going to have that finish. There's a possibility if you're cramped for space, if you don't really have room to put the surface symbol directly in there. But that's not a problem for us right now. So I go back to the window that all of you opened. In this case, we want whoever is manufacturing this to buy from their supplier a 10mm plate, and we want them to simply cut the outline of the plate. So we don't want them to do any treatments to the top surface or the bottom surface of the plate. We only want them to cut it. So I'm going to give a general surface finish where I'm telling them that removal of material is required. Here. So I click that one. And then I go to the A section and I put in R, Z, capital R and a lowercase z. And I put in 50. So that's a very rough surface finish. And it's very possible to manage to get such a finish using a water jet cutter or a laser cutter or a plasma burner. So it's fully possible to create this one with this surface finish, just cutting it. So I click OK, and now my symbol has been updated down here. But I also want to make it absolutely sure to the manufacturer that they don't need to do anything to the top or bottom of the plate. So then I go up to the surface symbol, click that again, and I'm going over to the projected view on the side here, and I am attaching one symbol to one side of the plate, left mouse button, then right mouse button, and continue. And I'm going to choose the removal of material prohibited option, which is the third one up there on surface type. And this means that they're not allowed to touch that surface. They're not allowed to cut it in any way. And since they're not allowed to do anything with it, I don't need to specify any particular finish. They're just going to leave it as it is. So I click OK. And then I do the same for the opposite side of the plate. Left mouse button, right mouse button, and continue. Removal of material prohibited. And click OK. So now they will see, this will tell them that it is fair enough to use whatever cutting machinery they have. And this will tell them that they don't need to use a milling machine to get the correct surface finish of the plate. Because if I hadn't put this one up here, they might have run it through a milling machine, shaving off just a couple of micrometers of the surface, of the top and the bottom, just to get the correct finish for it, just to get it smooth enough. Now we need to add another text box. I prefer to put it down in this corner, but it doesn't really matter where you're going to put it. It's a note text box where you put additional notes with regards to the production. So I click the text function up there. I place the text box somewhere in the proximity of where I want it to be. And now I'm going to write in here, I'm going to write notes. And in this case, I only have one note. So my first note is to break sharp edges. And I want them to be broken by 0.2 millimeters at a 45-degree angle. And for the angle symbol, you can use this button up here and click that one to get it. The reason we add this one is that once this plate has been cut, it's going to have fairly sharp edges, which you can actually cut your hands on. And by adding this one, we're telling them to either use a light grinder to grind the edges slightly, or just to use some rough sandpaper and just sand the edges so that they sort of blunt the sharpness of it. Once we've written the note, we press OK. And now I can move it down into the corner just to get it to look a bit more nice. So whether you place it in this corner or if you place it over here, doesn't really matter. Now the only thing that's missing on this drawing is to fill in the title box. I'm just going to let people catch up a bit before we fill in the title box. Marken går merkbart fortere for hver forelesning, så veldig bra. Jeg tror vi skal klare å tegne igjen det.
Ja, noen sliter veldig med, altså. De fleste er jo
Sånn er det uansett, det vil alltid være noen som sliter.
Jeg er overrasket.
Jeg synes det er veldig bra. Right, in order to fill in the title box, we go over to the browser tree over here, and we pick out the ISO part. And you can even see in the icon there that the title box is highlighted. So we want to open it up using the arrow on the side of the ISO part there so that we can see field text. Then we mark field text, right click, and then we choose the edit field text. Then we get this window, and many of you probably have a window that looks more like this, that you can't see all of the lines in it. Then I would advise you to drag it to get it to show all of the lines. That's a bit useful when you're going to fill this in. You can't add any information directly in here, but we can open the properties part. And then in the different tabs here, we can find all of the lines that we need to fill in here. So there are none in the first one. So I continue on to summary. Title is the first one here to fill in. And I'm just going to straight out call it plate. Author is the second one to fill in. It is usually automatically filled in with your login name for the Windows system. So in my case it's my initials, but I'm going to change it to my student number, which is what you will most likely have on yours, and what you have to have on your submission. You need to put your student number, or else I'm not going to see whose drawing it is when I'm correcting it. The next one to fill in is company. And here you can put in your fictitious company if you want to, or you can just write the name of the school. And we continue to the next tab, which is projects. And here we need to fill in the first one there, which was marked part number. This one will be automatically filled in if you have already saved your drawing. I had forgotten to save my drawing before I started to fix this, so I have nothing on part number there. So I'm going to add plate. Ja. Det räknar jag nästan med. The next one is revision number. And since this is the first edition of our drawing, we're going to use either the letter A, or we're going to use the numbers 01 or something. It depends a bit on your company what kind of revision system is used. I'm most familiar with using letters, so I use an A. And then if 2 months from now, in a working situation, we had come back to this one and figured out that one of these dimensions isn't working, we need to alter this dimension, then we would alter it, but we would also switch from A to B on revision. Because then, when the guys were manufacturing it, they would see that this one says B on revision, so something is different from the last time when we manufactured this plate. So that's the whole point of having the revision numbers. Then I continue on to status. Checked by. In my case, I'm just going to use Torbjörn, as I always use. And Einar, as approver. Also for approver, you need to check the date mark below there, either with your mouse button or using your tab and spacebar. Because this date is going to show beside the approver initials. For your submission, I would recommend that you team up with the members of your team project, of your project team, basically, and have them actually check. Don't just write in their student number or initials as checker and approver, but have them actually look at your drawing and tell if they see. Maybe they see that, oh, you've forgotten to put in a center line or a symmetry line here, or maybe I think you need this dimension to actually be able to manufacture this one. So it's quite useful to actually use your fellow students as checkers and approvers. Once this is done, I press OK. And now I can just check here that all of my lines have been filled in. So if there are some of these lines that aren't filled in, I have to go back into the properties and try to figure out which one it is I'm supposed to fill in. And once that is done, I press OK. And my title field has been completely filled in. So then we do a 15-minute break. Right, we actually managed to finish off this drawing before the break. So I'm just going to save it before it's too late. This. And now we're actually going to start on the third practice task. So this one, where we have 3 holes, and we also have a counter bore on the center hole there. So I'm going to show you basically the quickest way of creating it. I'm going to close off this one. And I need to create a new project. New project there, single user project. I find my H drive and the correct folder, and I create a new one here. And again, always the problem here, it hasn't actually marked the new folder that I created, so I need to switch around a bit here just to get it to actually mark the correct folder. I click OK. And I also switch the name to practice task 3B. Then I click finish. And now I have practice task 3B marked with a black check mark. So I click done.
So you just save it, and then you went out, yes, and then you made a new project. You made a new project. No, this is a new one. This is a new one.
The next step is to create a new part file. So I go up to the new button up here. And since I'm in a new project, I have to re-choose the metric folder there. Just make sure you do that one. It's pretty annoying when you start creating a new part and then suddenly as you've gotten along into it, you realize that everything is in inches. So you have to restart from scratch. So that's a bit annoying. So always make sure you're in the metric folder. And again, we're going to use a standard part file. And we click create. So the idea for this one is that it is symmetrical, both horizontally and vertically. So what we can actually do now is to create 1/4 of the outline, and then we can mirror it once, and then mirror all of it a second time. So I'm going to start a new 2D sketch. I'll put it on the horizontal plane, which is my preference. If you want to use one of the other planes, you are free to do so. And again, for some reason, it tilts the view 90 degrees when I choose the horizontal plane. So I just tilt it back so I get it the right side up. And now I'm first going to create a few construction lines. So I'm going to mark the construction line option over here. This one. Construction line. And then I'm going to mark the line option there. So the first thing I'm going to do is to create a line going from the center and straight up. And it's going to go 40 millimeters straight up because the curve on the top here has a radius of 40 starting at the center. So I need to go 40 millimeters up to get to the top. So I attach my line to the center point there. I pull it upwards. I make sure that I have this constraint mark here that is going to constrain it at a vertical point. And then I'm going to write in 40. So then I get a line that is exactly 40 millimeters straight up. Now I'm going to create another line. And it's going to go from the center and off to the side horizontally. And then I want to have it between the centers of the center of the middle hole and to the center of one of the side holes. And that's 90 millimeters. So I create a new line. I attach it to the midpoint of my coordinate system. I pull it off to the side here. I make sure that I get this horizontal constraint symbol showing. And then I write in 90. And now I'm going to continue on with a new line from the same point where I stopped the last one. So I don't need to exit the line function. Because now I want to give this tip here, the radius here, from the center and out to the tip. It has a radius of 20, so I need to add a line of 20 out here, like this. And then I can exit the line function. I'm actually going to keep the construction option on right now, and I'm going to create two circles. So I go to the circle option, and I want to use the first one where I'm creating a center point and I'm setting the diameter of it, or the radius is what I'm setting. So I click this one. And the first one I'm going to place here at the center of my coordinate system, and I'm going to attach it to the end of the 40 millimeter line. Now I have this circle. And the second one, I'm going to attach it at the end of the 90 millimeter line, and then to the end of the 20 millimeter line. So the center of the circle ends up between the two lines here, and then I'm going to pull it over to the edge there and attach it. I'm going to just zoom in a bit so that it's a bit easier to see up on the screen here. And now I'm done creating these construction lines. So I'm going to remove this option, exit my circle function, and remove the construction line from it, because now I want to create continuous lines. And the first one I'm going to do is to create a regular line. And I'm going to attach it somewhere up here on the large circle. I'm going to pull it over to the smaller circle. And now I need to start moving it about a bit here, because I want a special symbol to be shown for constraint. So if I move it up here, it tries to constrain it to the top point of the circle. That's not quite what I want. I want a bit further in my case. It might be somewhere else on yours, depending on where you placed the starting point of your line. But what I want is this symbol here. So I want a small circle with a straight line tangent to it, because that means that I'm constraining this line to be tangent to the smaller circle. So I place it there. And now I get this symbol showing here, showing me that I've succeeded in constraining it to be tangent. So if we follow the curve here now, we can go straight over to a straight line there without any problems. So then I exit the line function, because now I want this end of the line also to become tangent with the large circle. So then I go up to the constraints part, and I find the constraint that is named tangent. I mark it. Then I mark the line and the large circle. And I exit the constraint function. So now I actually have, if I follow the curve here, I can go straight over to a straight line, and then I can go straight over to the next curve there. So everything is perfectly shaped there. But we need a little bit more in order to start mirroring this. We need the curve here, and we also need the curve here to be shown. And to use those, I'm going to use the arc function, where we create parts of a circle, but not a complete circle. So I'm going to use the drop-down menu, because I want to use the option where I'm placing the center point of the arc, and then the two endpoints. So center point, and then we place the center point first, I think it is. And then we start off with the starting point down at the corner here. Place this one, and then I pull it along the circle until I hit the continuous line up there, and attach it to that one. So then it goes perfectly there. I'll just give people a chance to catch up a bit. Now we're going to do the same for this curve. So we're going to use the same arc function. That's why I haven't exited yet. I'm going to start off in the center, placing the center of my arc.
Are you pressing right button or what are you pressing? So left button.
And I move straight up until I get to the top point of the circle. So I place the start of my arc there. Then I move it along the circle until it automatically attaches itself to my tangent line there. So I place it there. Now I have 1/4 of the outline of this plate. So I exit the arc function. So then we're going to start mirroring stuff. So I go to the pattern part. I click mirror. First off, I need to select the lines that are going to be mirrored. So here it can be wise to zoom in order to get a better hold of them. Here it wants me to mark the construction circle first off, So I just let it hover for a while, then I open this drop-down menu, because then I can choose the arc that I just created instead. Zoom out. Then I also select the tangent line. And then I go in here, let the mouse hover a bit in order to avoid marking the construction circle. Use the drop-down menu and choose the second curve. I would recommend manually selecting here in this case and not doing a selection box, because when you're dragging a selection box across it, it is very easy to select your mirror line also, and then it's not going to work. You're just going to get an error code instead. So then I'm going to place the mirror line, and I'm going to choose the horizontal one here. So either one of the horizontal lines will work. And then I press apply, because this is one of the few functions where you can't just simply press done directly. You have to press apply for it to work. But that works well for us in this case, because we are going to continue mirroring. So we want the window to stay open. So again, I'm going to mark my curves. The tangent line. And all the way around here. Until I've gotten all of the continuous lines marked in a bright blue. Then I'm going to select the mirror line, and I'm going to select the vertical line, construction line from the start. And again, we have to click apply. And then done. Now this part is fairly simple, so I would probably not be saving much time in doing this double mirroring, just drawing a quarter of it and doing a double mirroring. It's probably taking me about as much time as just drawing the entire outline directly. But the reason that we are practicing using the mirrors and pattern functions is that they are highly effective when you get onto more advanced stuff. So it's nice to just get a lot of practice using it. Once this is done, we have the entire outline. We're going to wait with creating the holes until we have created a solid plate, because then we're going to use the hole function afterwards to create the holes. So now we use finish sketch. I'm going to zoom out so we can see it a bit better. And then we're going to extrude it. And in this case, we're supposed to have a 20 millimeter plate. Yeah, and I also have to choose the profiles, because for some reason it hasn't marked everything in my case here. Let's see. One dimension either. Uh-huh. Right, for some reason it hadn't gotten all of the constraints in place when I did mine. It still doesn't want to mark it. See? Ah.
Kan det om konstruksjonslinjen? Ja, for det klikker litt på den normale konstruksjonslinjen.
Det er det åpen loop. Right. Now I fixed the problem. There were some of my constraints that hadn't been in place when I created the original quarter. So when I was mirroring it, I was not putting all of the constraints in place. So it just took a while in figuring out where all of the constraints were missing. So then we are extruding it to 20 millimeters. And then we'll start off by creating the side holes. So I go up to the hole function. And in practice task 2, we use the linear option for placement. But on this one, we're going to use the one that's called concentric. Because we have curves on the edges, and we also have curves in the middle, so that we can use those as a reference for our center point. So for plane, we select the flat of the plate. And as concentric reference, I'm choosing one of the edges right now. I want the termination to be through all, because I want the hole to go all the way through. And the diameter of my hole is supposed to be 20 millimeters. Once that is done, I can click Apply, because I want to place another hole. So if I click OK instead of Apply, then I have to re-enter the hole function. Now it remembers that I'm going to use concentric. So again, I choose the flat of the plane, the flat of the plate as my plane. And for concentric reference, I now choose this curved edge. And it remembers that it was supposed to be 20 millimeters, or at least that the last hole was 20 millimeters. So I can press Apply. I'll let people catch up a bit before I place the middle hole.
to choose a reference for where the hole is going to be in the center. So we want it to be in the center of this reference, right? We want it to be in the center of this reference here. You have to click that reference. Yeah. Go to the center of that. Okay. Then you press apply. Okay. Now the next one. So it says plane, so then you choose this plane. And then it says concentric reference. So where, because we have concentric here, that's why. So where is the concentric reference for the next hole? Where do you want it to be? Yeah. So now it's in the middle of that, and it's 20 millimeters, which is okay. So press apply. Now you're where you get. Yeah. So concentric means that if you look at this, you see the purple one inside. It's in the center of a bigger circle. There, linear is then you have faces. Then you have the reference from the side, from the bottom. Then it's square. So when it's round, you want it in the center. Then you use concentric. Now in the next one, we're going to make a hole in the center here, but it's different. It's not just one hole. It's more like this. So it goes down one, and then down is different. So you have to.
These are the only curves that are in place. These are all of the rest.
We'll go after, but if you want to look at it, you can see first it's a big hole, goes down a little bit, and it's a smaller hole. So that's what we'll do.
These three dimensions, we need to figure out which dimensions. That means one dimension. There's something there.
Du har kids då?
Ja?
Du har kids?
Samtidigt så kommer man ta lite. Hur blir det sig? Lite liksom på morgonen så.
It's a bit difficult to say exactly where that one dimension is missing right now, but it's definitely the other something that is missing. It didn't need that one dimension, so that's good.
När ska spela? Han kan släppa den 20 millimeter linje då. När jag fick overtrain sketcher.
Ja, når du går nedover har du klart å merke
det merker kun
hvis du har select på middelveiene.
Nei, jeg hadde
så velger du som middelveien.
Jeg gjorde 3 ganger.
Ok, ja, men da
Nei, for jeg tok vekk den 20 millimeter linjen. Så fikk jeg. Men jeg vet at den ikke må merke, altså.
Ja, nei, da vet jeg det.
So for the center hole, we'll use the same concentric placement. We select the flat of the plate. Yeah. And as a concentric reference, we're going to choose the curve here. And that places this hole straight in the middle. But as we can see from our model, we're supposed to have a counterbore on this one, so we can't have a hole straight through. So if you were doing this with extrudes, you would have to first create one of the holes, and then you would have to create the counterbore. But since we're using the hole function, we actually have the option of doing everything at once here. So instead of using a regular drilled hole, as we have up here, we go down to using the counterbore hole. And then we can set the diameter of the counterbore itself, which is supposed to be 40. And we can set the depth of it, which was supposed to be 5. And it remembers that the center hole was supposed to be 20. So here you can see you get to do everything at once, which is a good way of doing it. Then we can press OK. And this part is supposed to be made from stainless steel. So we'll go up to the material up top. Open up the drop-down menu. And we'll just scroll down until we can find the stainless steel. And then it turns pretty dark. Now I need to save it. And I'll call this one a mount. And click save. Then we got 5 minutes to actually start the two-dimensional drawing for this one. So I'm going up to the blank sheet up there, the new button. And again, we want to use the metric folder, and we're going down to the iso.idw file. Once you've chosen the iso.idw file, you can click Create. .idw. We still have the mount that we just created open in the part file down in the tab here. So I'm going to just click the base view button, and then it automatically selects the mount part for me. I don't want to look at it this way, so I'm going to flip it around to the top so that I'm looking straight at it. I'm also checking to make sure that I have hidden lines removed on this one. And also it looks a bit small, so I'm going to change the scale of it. So I'm putting it to 1:1, just to get a bit more to show my dimensions on. Then I click OK.
Når du har innleveringene, da får du partfiler og alt, sant?
Ja.
Har du noen krav til at de skal gjøre det, for eksempel at de skal bruke hold-funksjonen, de skal bruke den funksjonen, eller er det bare å gjøre som de vil?
De får lov til å gjøre så det.
Ja.
Det gjør det. Jeg kikker over det, og så kan det være at det kommer kommentarer.
Ja, for det må man si slik med alle andre funksjoner enn extrude. Det er sketsj på sketsj, og så alt er ekstrudert, liksom.
Ja.
Men jeg forstår ikke det.
Ja, det går an det. Så.
Ja.
Right, when we've gotten the mount up, then we also want to show it from the side. So we're going to flip it up here, but we're going to show a section of it. We're not just going to show a projected view up there. So instead of just flipping it up here and looking at it from the side, we're actually going to create a section view through here, and then we're going to look in at the center of it instead. So in order to place a section view, we go up to the button that's named section up there. We click this one, and then it wants us to select which view we are going to section first. So then we just make sure that we have this red rectangle across our view, and then we click it. And now it wants us to place the line where we are going to section it. And in this case, we want to section it straight through the horizontal symmetry that we have. And in order to manage that, we are first going to locate the endpoint here, the midpoint of this curve. So I've just moved my mouse pointer across it. I've gotten the green dot there. And then I'm going to move my mouse pointer off to the side. And then you see I get this dotted line over here. And this is because the section line is never supposed to start directly on the part. You're supposed to start outside the part and then go through the part. So I place the starting point of my section line and I pull it across the part. And now you see I've got it at an angle. I want it to be horizontal, straight through. So I'm going to move it a bit down. And then it snaps on to being horizontal. And then just to make this pleasing to watch, I'm going to try to get approximately the same distance past the part on each side. Then I click my left mouse button to place the endpoint there. And as you can see, I can continue on creating the section line if I want to. And that's if you're going to make very complex sections with several planes. But we're not doing that now, so we're just going to click the right mouse button and continue. And now we need to place the section where we are going to put it. So I want to put it a bit further up. And I'm also just going to look over the information we have here. We don't have any other sections or anything, so it's nice to use A on this one as a view identifier. Because Inventor is going to continue with the next letter for each view you create, even though you have deleted a previous view. So that if you have A, B, C, D in your different views, and then you delete your C view, the next one you place is going to be automatically named E instead of C. So then you can go in and manually change it so that you have it alphabetically. Because if you don't have it alphabetically, whoever is going to produce this part, they're going to be looking at it and are going to say, well, I can find the sections A, B, D, and E, but I can't find the C one. So where is it? Is it there's supposed to be another sheet here? Where is it? So you're just going to create a lot of confusion by not doing this alphabetically. You also have the option of changing the scale if you need to blow it up a bit to get to show all of your details. Then when you've figured out where you want to place it, you just click your left mouse button. And then you've gotten it there. We've got a nice section line showing where we're cutting through our parts. And we've got it all showing up here. So we'll stop there for today and we'll continue on next week.